There's a few subjects that I wanted to go over today, and I'll probably have to do it in 2 videos. But the first subject I wanted to go across was inrush current. What is inrush current? When we have a coil of wire, which is known as an inductor, let's say I have a DC relay. If I measure the resistance of that coil inside the DC relay, I can accurately figure out how much current that coil is going to use just by looking at the voltage and dividing it by the resistance, and that gives me the current. It's just Ohm's law. So if I have a 12-volt DC relay and it has a resistance of 120 ohms, then I know that that relay is going to consume 100 milliamps of current. But you can't do that with AC inductors. With AC inductors, we have a property that's called inductive reactance. Inductive reactance is kind of like resistance. Actually, it's the opposition to alternating current. Actually, it's the opposition to any change in current. But the reason why we can't accurately predict how much current an AC coil is going to consume is because of that unknown factor, that X factor, which is inductive reactance. Now, I measured the ohms of this 24-volt AC relay, and it measured 70 ohms. And if I apply the math, you take the 24 volts divided by the 70 ohms, and you come up with roughly 342 milliamps of current. Now, initially, that's true, but after a few milliseconds, this inductive reactance kicks in, and that's going to bring that current way down. So this initial high current, we refer to that as inrush current. And until the inductive reactance builds, this inrush current is going to be much higher than the normal current. Let me demonstrate. Right now, like I said, the ohms was 70 ohms, and I figured it should draw about 342 milliamps of current. We'll see how much we get. $291 milliamps, pretty close to the 340. Now, that's because I recorded it on a high speed. If I take it out of the high speed record mode, you'll see that the actual holding current is much less. Matter of fact, it's only like 127 milliamps. But that's what an inductive reactance is. It's that extra resistance to alternating current.